How's it going? I know we've been talking about standard normal distributions for about 2 weeks now, and now we're going to talk about standard deviations. Okay, now standard deviations were something we used with standard normal distributions, but it's something we kind of we talked about right before all this stuff happened and we got kind of kicked out of school. So I want to show you guys what exactly a standard deviation is, how you calculate it, and then over the next few days why you don't want to do this by hand every single time. Okay. So I don't want to scare you guys away because there's a lot of symbols in here and there's a lot of things like that that you guys might see and get a little intimidated by, but there's really nothing about this that we can't do without a little help from the calculator. It's a lot of adding, subtracting, multiplying, and dividing. What you're going to see, though, by the time we're done with this process, though, is that it is a bit time consuming and that there are better, more efficient ways to set this up and do it, okay? So let's start off with the definition. The standard deviation is used to tell how far, on average, any data point is from the mean, okay? Now, the mean is an average itself, right? So we're looking for the average distance away from the average of all the numbers, okay? And that's what a standard deviation is kind of all about. The smaller the standard deviation, the closer the scores are on average to the mean, okay? In other words, if you thought about all your data, if your standard deviation is a small number, then that means everything's compacted right around the center, okay? So when the standard deviation is large, though, that means the scores are more widely spread out from the mean. Now, what we've been talking about for the last week or so is standard normal distributions, where things have the same mean, median, and mode. If you take a look at the numbers we're starting off with, they do not have the same mean, median, and mode. They do not. So this is not normally distributed, but we can still find the standard deviation of things like that, okay? So last week they were giving it to us. Here we're going to go ahead and find it ourselves, okay? So I want to show you guys a couple symbols that you're not going to freak out about when you see, okay? N, very simple. The number of terms you have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, before you guys start losing your minds, I don't know what N is. N is pretty straightforward. So I'm going to try and write on this with a pen. Oh my God, where's my eraser? See, I messed up already, guys. Okay. So again, what do we got? N is 10. Very straightforward, right? There's 10 numbers. That's it. Okay. All right. Now the mean, which we're also going to call X bar, right? So each one of these numbers is X, and they will be, right? So we'll start with 22, and we'll work our way down. X bar is going to be the mean of all these numbers. Now, you guys know how to calculate a mean, right? We're going to go ahead and we're going to add all these numbers together, and we're going to divide by the number of entries. So we're going to say 22 plus, thanks, Microsoft, 22 plus, I'm still recording? Good. Okay, 22 plus 99 plus 102 plus 33 plus 57 plus 75 plus 100 plus 81 plus 62 plus 29. Okay, it's 660. That's our total. Then we're going to divide that number by the number of entries we had, which we said was 10. So what's your mean? Your mean is 66. Okay. If you guys are going to do those all as one step, remember what I was telling you guys beforehand. Make sure these numbers are inside parentheses, and then you divide. Okay. So what we're going to do is we're going to fill out this chart. Okay. The first thing we're going to say is what were the test scores. So we had a 22. No, off. All right, there we go. 22. We had a 99. We had 102. We had a 33, a 57, 75, 100, and 81, 62, and 29. Again, if you were making your own chart, you make however many entries there are for the data that you're given. Okay. Good. Your second one is what's the distance from the mean? Okay. In other words, how far are these numbers from the mean? Okay. So it's pretty straightforward. All we got to do is take this number and subtract 66 from it. Okay. So 22 minus 66. 22 minus 66. Negative 44. Don't freak out about the negative numbers. In fact, we don't even really need to be concerned that they are negative numbers, okay? So again, how far is this number from the mean? It's 44. How far is 99 from 66? 33, right? So again, what do we say? 33, I'm sorry. Oh my God, I broke it. Okay. What are we going to say? We're going to say 66 minus 99. I'm sorry, I messed up again. 99 minus 66. It doesn't matter. So again, how far is this? It's 33. All the sign is telling you whether it's bigger or smaller, okay? So this will be a positive number. 102 minus, sorry. Again, 102 minus 66. Okay, 36. 33 minus 66. Okay, so we got 36 negative 33. Okay, so I'm going to kind of do the next few all together, and we will take it from there. Okay. So again, what do we got? 57 minus 66 is negative 9. Again, there's some of these you can do inside your head. How far? 75 minus 66, 9. Right? What's 100 minus 66? 44. 81 minus 66. Again, like I said, if you can do them inside your head, do them inside your head. If not, you can go ahead and you can just use the calculator. So 81 minus 66 is going to be what, 15? I think. Probably should be doing these in the calculators to make sure. What's 64 minus 66? Negative 4. It's 29 minus 66, like we said. 29. Oops. Did not do it. 29 minus 66. Okay. Negative 37. Okay. Great. Now it's all good. Again, what do we have to do with these numbers now? We have to square them. So now we're going to take every one of these numbers and we're going to square it. So I will give you guys a piece of advice. Once you know how to do this, you're going to do these all at once. You're going to do 22 minus 66, square it. 99 minus 66, square it. Now, because we're squaring it, we're not even really concerned about the signs, okay? So we have 44, oops. Oh my God, oh, that's why I've been doing adding to the end here. Okay. Again, what's 44 squared? 44 squared is going to be some huge number, 1936. Okay, so, oh my God. I just want to draw on here. Can I just draw on here? Please, what? No, just write. I want to write. Why can't I write? Guys, when they tell you teaching from home is going to be easy, they're lying. Okay, so am I drawing on the screen? No, am I drawing it? No, why am I not drawing? Sure. 1936, okay. 33 squared. 33 squared is going to be 1089. 1089. Now, just as a little quick thing, 44 squared down here is going to be the same thing. And 33 squared down here. So another one is also going to be the same thing, okay? So again, negative 33 and positive 33 squared both give you guys the same number, so you can save yourself a few steps there. 36 squared, 1296. Okay, negative 9 squared, oh, we know, one that we know, great, 81. 9 squared is also 81. 15 squared, I'm going to tell you guys, is 225. Okay. 4 squared is going to be 16, and negative 37 squared. That one I don't know off the top of my head. 37 squared is going to be 1369. So again, word to the wise, all of your numbers in this column should be positive. Okay. If you have a negative number, it means you messed up putting the numbers in your calculator. Please be careful with that. Okay. Now, what do we need to do now? Sum of the difference of the mean. Well, that was the difference of the mean, right? So what do we do? Took our numbers, subtracted them from our mean, squared them. Now we need to add up all those numbers together, okay? So again, basic calculator work, 1936. Oh, no, it's not going to work over here now. 1936 plus 1089. Oh, God. Did I delete something? I did. Oh, my God. I hate your smartboard. I can't even blame the smartboard this time, can I? How do I just go to home? Undo. All right, there we go. Is that better? 1089 plus, oh my God, plus 1296 plus another 1089 plus an 81 plus another 81 plus a 1936 plus a 225 plus 16 plus a 1369, and that will give us a total of 9,118. Pretend like this will work. We're drawing, choose black. We're going to write on here. It's not going to work. It is not going to work. Sure, let's try this work before, right? 9,180. All well and good, right? Okay. Now, again, this big fancy symbol right here just means add them up, okay? So we've just found that, okay? So, sum of the difference from the mean divided by the degrees of freedom. All you got to do to find the degrees of freedom, take this number and subtract 1 from it. So what's 10 minus 1? Probably the easiest question on this goal here is called 9. So what do we want to do? We're going to take this number here that we got, and there's a square there, 9,118 divided by 9. Okay, what do we get? 1,013.1 repeating. Okay, that's called our variance. What we want to do now is we want to take the square root of that number, which is 31.82. 31.82. Okay, so again, what is this number down here? Which again, we rounded, I'm sorry. It was 31.82940, so, you know, irrational number more than likely. Again, what does that mean is that if we average out all these numbers, how far is each one's distance away from the mean as an average? Okay, so you're about 31.82, which means you have a pretty good size standard deviation. I mean, these numbers are not clustered very close to one each other. Again, when that's regularly distributed, no, I'm sorry, normally distributed, that has a special meaning, and we'll talk about that kind of as we get to it, okay? If you guys want to give one of these a try tonight on your own, they're not too hard. There's only a few numbers here, so you guys should be able to do that. You can just follow these step-by-step things, okay? Find your mean, count the number, add them in, subtract, square them, add them, square root, and kind of put them all together. So we'll do one more of these tomorrow by hand, and then we'll take it from there. I'm sorry, I'm having a little bit of problems with the Microsoft recording thing, so I will try and record another one and put it up there. Maybe I'll do the second one as an example, but you guys might have to live with this one for now until I get the kinks kind of worked out. So anyway, like I said, give it a try as long as you have a rough idea. What we're going to talk about over the next few days is how we can use technology to help us out a little bit, because honestly, there's a lot of moving parts here, right? There's a lot of opportunities to make mistakes here. So one of the things we can do is what we were doing before we were kind of split up and kicked out of the school, was we were using Excel and Microsoft Sheets to go ahead and give us a hand doing stuff like this. So what we'll do is I'll show you guys how to enter all this stuff in, how to program summations and things like that, and you guys can take it from there. So like I said, I can try and record another one, but if not, you guys might be stuck with this one. But kind of long story short is this. Calculating standard deviation, none of the math is very hard, right? The calculator does all the math for us, but the number of computations is a lot, and if we can get a computer program to do all those computations for us, we'll be a little better off, okay? So again, real quick, what do? We found the mean of these numbers. We found the number of entries. We put all of our entries here. We subtracted them from the mean. We squared our results. Okay, added all those together. Okay, that's summation. We just add all those numbers together. What do? We divided by 1 less than this number, so not 10. We divided by 9, that's called the variance, okay? We got, we divided by the degrees of freedom, got the variance, okay? And we went ahead and we took the square root of that number. So again, what'd you do? Numbers, subtract the mean, square it, add them together, divide by n minus 1, take the square root.